Hi everyone. Today we are going to be discussing the Physics 110 lab, Ohm's Law, for the Sierra College Physics Department. We're going to be measuring both ohmic, non-ohmic, and yourself as a resistor. Part 1 is going to be using a variable DC power supply, an ammeter, a voltmeter, and a large resistor. This resistor is measured by the banded colors: green 5, blue 6, brown multiplier of 10, and gold, which is a plus or minus 5% tolerance. This is read as 56 times 10, or 560 ohms, with a plus or minus 5% tolerance. We also need to measure that. I will set this meter to measure resistance, and the resistance across that resistor is 0.583 kiloohms, or 583 ohms, which is within our plus or minus 5% tolerance. Now we need to hook this resistor up so we can measure both current and voltage. Current is measured in series, so I'll hook up the variable supply to the resistor. The resistor to my safe range of milliamps. If you're in the wrong range or too small, depending on your setup, you may blow a fuse. And COM back to the voltage supply, thus completing the circuit. Next, we'll add in our measurement for voltage. That is done in parallel. So the leads go right across the resistor block. I will set this to measure DC voltage. This to measure current in the 430 milliamp range. And I'll turn on my voltage supply and get readings of, this says 5.2 milliamps and 3.036 volts. You're going to take measurements over the range, jumping up by how many you need, and this has a 0 to 20 volts. You'll take these measurements and plot this to determine the resistance of this block another way. Now moving on to part 2, I'm going to take apart my circuit. And move over to this larger lab supply. This lab supply can generate far higher currents and higher voltages than the one to the left. We're going to be using a light bulb this time. You'll see that this light bulb acts as a resistor, and it is that, but it's also a non-ohmic device. The light bulb itself gets very hot, and as you know, temperature can affect resistance. So I'm going to hook up my light bulb in the exact same fashion as before, but this time I'm going to use the 10 amp setting. I complete the circuit for the ammeter. I will attach the multimeter across in parallel, set to DC volts. This time I will go to the 10 amp setting. And that's a little bright. So we're going to start it low again. And we're going to measure, again, the current and voltage as you go up in different increments. So I reached 43 volts and I'm at 0.47 amps. That's the reason why I'm in the 10 amp scale. I've already exceeded my 430 milliamp setting. Again, take voltage and current readings as you go through your entire range. As we see this bulb getting brighter and brighter, that is heating up. Once you've completed it and that's sufficiently hot, we're going to remove it from the supply and measure the resistance across the bulb. Note the resistance from before and from after. and you will do a plot over the range. Lastly, as I move the camera, this is the lethal voltage spot. Don't worry, this is completely safe. But we're using this to estimate what our resistance is, and again, what our lethal voltage would be necessary to kill us. I have a battery supply, or a voltage supply here, set to 3 volts. And I'm going to place my fingers on this, thus completing the circuit, and I'll measure my current that is going through the circuit and the voltage. So with my fingers on this, I'm approximately 3 volts at 12 to 14 microamps. You're going to do this measurement again with a wet hand. Go over to the faucet, wet your fingers, put them on again. Note the difference between 1 and 2. You will be less resistant with wet hands. You're going to use those in your calculation to determine your lethal voltage. It might be anywhere between 50 or 50,000 and up volts. And that is the lab for the 110. You're going to be given data sets for this lab. Please complete those. If you have any questions, let your professor know. Thank you and enjoy your day.